Hello everyone. This video will be on the 3.11 section of the IBAA curriculum. Please pause the video for a second to look at the concepts and contents for the section. There's no formula. One sentence that summarizes this section is, trigonometric functions are related by themselves and by other trig functions. First, we have to think about the cyclic nature of the trigonometric functions. And because they happen on and on and on, repeatedly, if we do some horizontal shift, we can say that the function remains the same. So let's first look at the sine function. And I can notice that the period is 2 pi, from 0 to 2 pi. So that means that when I do a horizontal translation by 2 pi, we probably get the same graph. So we can conclude that the sine x is equal to sine x minus pi, or sine x minus 2 pi. And this happens the same for the cosine and tangent. What if we're doing a vertical reflection? Let's try to look at the negative sine x. And we'll try to get to the negative sine x by doing some horizontal shift, okay? And I know that usually my sine x starts from 0 and goes upward first. And we can see that, oh, that cycle starts over here. So I can see that, oh, if I do a shift of pi, horizontal shift of pi, we'll get the same graph. So let's do x minus pi. And we can see that we get the same graph. This works the same way for the cosine as well. However, the tangent x doesn't work the same way. Let's look at the negative tangent x. Unlike the usual tangent x, I can see that the negative tangent x goes downwards, right? I can't replicate this by doing horizontal shifts or vertical shifts. So that means I have to do some horizontal shift as well. Horizontal reflection. So let's do the tangent of negative x. And we can see that we get the same graph. And if you remember from the topic 2, this explanation is the same as the odd and even function. From this, we can conclude that the tangent function is odd. And let's try the same for sine x and cosine x. Negative sine x and sine of negative x. And because the two graphs are same, we can conclude that the sine is also an odd function. Let's do the cosine. For cosine, however, the two functions are not the same when we do negative cos x and cosine negative x. Let's try the non-negative version, so cosine x and cosine negative x. And we can conclude that they're the same, so therefore we know that the cosine function is even. Lastly, let's think about how we can move from sine function to a cosine function, or cosine function into a sine function. Let's first graph the cosine and then cosine x. And we can see basically the only difference between the sine function and the cosine function is the starting point. The sine function starts from 0 and the cosine function starts on 1. So we can conclude that if we want to do a sine function to a cosine function, let's change the value, let's transform the sine function into the negative direction by pi over 2, which means I'm going to add by pi over 2. And we can see that we get the same graph. So we can conclude that sine of x plus pi over 2 is the same as cosine x. For the cosine x, however, we need to do a positive translation, which means that cosine of x minus pi over 2 will be the same as sine of x. So why are we learning how to do this? We learned this so that we can change whatever trig functions we're given. We can change it into another trig function. We can combine this knowledge with the compound angle identity, and we can simplify the function as well. For example, you could be given a composite function of the sine function and be asked to represent it using the cosine function. And we can use the skill that we have learned in this video to do just that. Okay. So let me show you an example of such question. Let's try to change this into a cosine function. And before I do that, let's just write down what we have to do to get to the cosine function. I know that sine of x plus pi over 2 is the same as cosine x, this is what we just did on the graphing display calculator. We know that to go from cosine x, we have to do minus pi over 2, the positive direction. Because we're given the sine function, let's use the second equation. And immediately we can change this so that it's 3 cos, everything except inside the cosine x's remain the same until we do a minus pi over 2. Okay. And let's simplify that. 3 cos 2x minus pi over 2 is 4 equals 3 cos 2x minus 3 pi over 2. And let's change it back into the form that we know of. 3 cos 2x minus 3 pi over 4 is 4. We're missing 1 here. Alright? And if you graph that on the graphing display calculator, you'll see that they're the same. And notice that this is not the only answer. You can always change the values and still get the same result. Okay? But this happens because of the cyclic nature again. I hope you enjoyed this video, and try some questions in this section to really master the skills that we have learned. Anyways, I'll see you in the next video. Best wishes.